Hi guys, it's Miss Hernandez. We're going to be covering Molar Mass. It is the first day of the spring semester, so I hope most of you guys got your credits as far as the class goes. If you didn't, I'm sorry, you didn't work hard enough. It is very easy to pass, but you got to turn in those review questions and those journals. All right, so Molar Mass, section 10.3 from your CK12 packet. Molar mass, I always like to tell my students, it's a conversion unit. It's a unit that helps us bridge moles and grams or mass. Okay? If you have the moles and they're asking you for mass, you're going to use molar mass to connect one to the other. If they give you mass and they're asking you for moles, you're going to use molar mass to connect these two items, okay? So think of it as a bridge. It's a conversion unit that connects moles and grams. And you got to remember, moles is one of those easy, it just represents a very larger number. It makes our numbers very much more manageable, okay? When creating a solution, how do I know how much of each substance to put in? So remember, anytime you're doing solutions, there's two components to a solution. The water, that's your solvent, and your solute. Okay? So this example, this introduction is going to talk about the solute. All right? So let's get started. Who's going to read for me?
I want to make a solution that contains 1.8 moles of potassium dichromate. I don't have a balance calibrated in molecules, but I do have one calibrated in grams. If I know the relationship between moles and the number of grams in a mole, I can use my balance to rule out the needed amount of material.
Thank you, Alexia. Excellent reading skills. So, I assigned Alexia, hey, Alexia, I need you to go get me 1.8 moles of potassium dichromate. And Alexia is going to go and she's going to go look at the balance and say, there's no moles here. The only thing that I'm looking at that's on the balance is the unit for grams. So what is she going to use? She's going to calculate the molar mass of potassium dichromate to change that 1.8 moles to grams because that's the only thing that our balances read. They do not read the unit of the mole. We have to change it using molar mass to grams. All right. So today is all about calculating molar mass. It's not about converting. Converting is more for tomorrow. All right. So let's see what the deal is when it comes to molar mass. So like I said, molar mass is a unit that connects the mass of a compound to moles of that compound. All right. And it's a concept that we're going to be using a lot throughout the spring semester. So make sure you're paying close attention. And if for some reason you don't understand, come see me at tutoring after school from 4:30 to 5 here on Google Meet. All right, so molar mass. Molar mass is defined as the mass of 1 mole of representative particles of a substance. Okay? So mass equals 1 mole. Now you can do the molar mass of an element by looking at the periodic table. By looking at the periodic table, we can conclude that the molar mass of lithium is 6.94 grams. So if you look at the square for lithium, there's going to be a lot of information, but there's always at least 4 items. The name, the atomic number, the symbol, and the atomic mass. It is the atomic mass that we're going to look at for these elements that gives us that molar mass. For lithium, 6.94. And as you can tell, they dropped that third number. You don't usually need it. As long as you go 2 decimal places, you're good to go. Make sure you round correctly. Since this 1 is smaller than 5, we keep 94. If it would have been 945, it would have rounded up to 0.95. But in this case, we don't round up because this number, the third decimal, is less than 5. For zinc, our molar mass would be 65.39. And the molar mass of gold, 1.96.97 grams. Don't forget the units, guys. Each of these quantities contains Avogadro's number of atoms, 6.02 times 10 to the 23rd of that particular element. So all of these numbers, 6.94, 65.39, 196.97, all of those are equal to 1 mole, which is equal to Avogadro's number. Does that make sense? And don't forget, the units for molar mass are grams per mole or G/mol. All right? So anytime you see these masses, 65.39, you're going to say grams per mole. And you're going to write G/mol. Okay? You must include your unit for molar mass because it is going to be important when using it as a conversion. All right, here you have your first pair deck question. Part 1. How do you find the molar mass of the element? What do I need from this page right here? I'm looking at this page right here. What do I need from this page in front of you? What are you going to look at? Are you going to look at the atomic number, the number on top? Are you going to look at the atomic symbol? Are you going to look at the atomic name? Or are you going to look at the mass, atomic mass of that element? What's going to help us, guys? I gave you 4 options. Atomic number, atomic symbol, atomic name, or atom's name, element's name, or atomic mass. What do you think? I'm looking at the chat. I don't see anything. Atomic mass. Very good. Very good. Very good, Diamante. Very good, ma'am. All right. So, now that we know where to find it, because Miss Diamante said that it's the atomic mass, which is the number at the bottom of the square. Can you find the molar mass for the following elements? Part 2. For carbon, sodium, and argon. It's the atomic mass. Why'd you delete it? You're correct, whoever this was. You were correct. It is the atomic mass. All right, now find the molar mass for carbon, sodium, and argon. Element C for carbon, which is element 6. Can you see these numbers, guys? Because I have a periodic table that's bigger. I know it's kind of hard to see because those numbers are not super clear. You can't see it, right, Caitlin? Okay, so right here, let me go to this periodic table. Carbon, sodium, and argon. Carbon is element 6. Argon is element 18. And sodium is element 11. That's the atomic number. I need the molar mass or the atomic mass of those elements. What do you think? Carbon, over here. What does it say here for carbon? Right here, guys. Everybody see it? Here, let me change it. What does it say for carbon?
12.0.
Thank you, Mr. Jeremiah. Okay, what about for argon? Argon, element 18. 39.948. Very good, sir. And the last one, sodium. 22.990. Excellent. Okay. I didn't pause it, did I? No, I didn't pause it. Okay. So what am I going to write for the last one? 16.01 grams per mole. All right. So now that I know that, I'm going to go to the next page and I'm going to make a list of my elements. Calcium, nitrogen, oxygen. There's two ways to do molar mass. Okay. I'm going to show you both ways. You tell me which way you like. Okay, so now let's look at the formula. And I need to decide how many atoms of each element do we have. So how many atoms do I have here for calcium if there's no number behind it? What is always there that you don't see? One. Very good, Miss Caitlin. So I'm going to put 1 times the mass of calcium, which is 40.08. So 1 times 40.08. And right now I'm not worried about units. I'm just worried about numbers. Okay, what about nitrogen? What is here for nitrogen that you don't see? Again, Miss Caitlin. 1. But you have a parentheses and you have a 2 on the outside. So what are you going to do with this 1 here and this 2 here? Multiply, add, divide, subtract. What do you think? What do you think? If you have a number outside the parentheses and a number on the inside. Add, subtract, multiply, or divide. Pick one of those 4 because it is one of the 4. Add, subtract, multiply, or divide. What do you think? Take a guess, guys. Take a guess. What do you think? Multiply. Yes, you are both right. We're going to multiply. 1 times 2, 2. So I'm going to put 2 times the mass of nitrogen. 1401.01. For oxygen, how many do I have if I multiply those two numbers? Be careful. 3 times 2 is 6. Be careful. I know. What do you think I told you, Urban? Now let's do the math. So get your cell phones because I know they're close by. Go to your calculator app, just like you see me do. 1 times 40, I don't really have to do that, right? It's 40.08. But 2 times 14? 282. 2 times 1401? 28.02. Remember, it's 14.01. So 28.02. There's a decimal in there. And then the last one, 6 times 16. Did everybody get 96? And the last part is to add. Okay? There's another way that you can do this math. You can do 1 times 40.08 plus 2 times 1401 plus 6 times 16. This is the way they show it to you when you get to college. Either way, it's going to give you the same answer. All right? So let's add them up. I already have 96, so I'm just going to add 28.02 plus 40.08.
164.1.
Yes, ma'am. And if you were to do the bottom version, it's going to give you the same answer, 164.1. And the unit for molar mass? Grams per mole. Grams. This is supposed to be a G. Grams per mole. Okay? Is that hard? Which way do you think you would like? The top version or the bottom version? Which do you think you'll make less mistakes with? Post it in the chat. What do you think? Some people like the bottom, but if you have a calculator like this, you can easily make mistakes. Okay? If you have a graphic calculator, well then you can verify your numbers as you put it in. But since we don't have graphic calculators and we only have what's at home, which in this case is a cell phone, I would prefer for you to do the top version. Whatever you feel comfortable, I am good with. Just show your work for it. Okay? Just show your work. In case you do make a mistake, I can go back and say, oh, he probably forgot to multiply this or that. And I'll just deduct a couple of points instead of getting it all wrong. If you just give me answers, guys, I can't give partial credit. That's why I always say show your work. Okay? And I do give partial credit. Okay? Because there is a lot of math that you have to do and people get confused. So I like to give partial credit for most, because you could have the correct process. It's just that you did something mathematically wrong. Okay? So I always give partial credit, but make sure you show your work. All right, if we look at the next page on Jamboard, you'll see that they got the same answer that we did, 164.10 grams per mole. Make sure to always include the unit for molar mass. All right, we don't have time to do, we might actually have time. We've been going really fast. Man, I got some really sharp kids in here that we've been going so fast. I guess we can do number 1 and number 2. Yeah. Let's do number 1 and number 2. Okay? So I know this periodic table is too small, so let me move on to the. So we're going to do KOH first, potassium hydroxide. Determine the molar mass of each of the following ionic compounds. The first one is potassium hydroxide. So we got 1, 1, and 1, right? Because there's no subscripts. So let's just look up the masses and add them up. All right, let me turn on. I paused it. Okay. All right, potassium. And write this down as you guys are giving me the numbers so that you can add them up, because you're supposed to be doing this one. Potassium, what's the mass? What do I have highlighted over here, guys? Potassium. K. What's the mass? Can somebody? Thank you.
39.698.
It's a 0. I'm sorry if I had my little cursor on it. It's a 0. 0.98. 39.10, right? If you round correctly. 39.10 if you round correctly. That's your first number. Plus your mass of oxygen. What do we say is the mass of oxygen if you round correctly? Do you remember? Do you remember? Do you remember? If you have 15.999, what does it round to, Caitlin?
16.
Yes, ma'am. Yes, ma'am, Miss Alvarado. And the last one, hydrogen. Oh, look at that one. What's going to round to? Let's see who can get it. Would it be 1.00 or 1.01? What do you think? What's that 7 going to make it do as far as rounding? 1.01 or 1.00? Look at the third number. If the third number, very good, Miss Alvarado. If the third number is 5 or larger, it needs to go up to 0.01. Just like uh I'm gonna butcher your name. Diamante. Diamante. Is there a certain way you say it, girl? I just don't want to mispronounce it. Okay. All right. Did everybody get those numbers? Start adding them up. Tell me what you got. So potassium was what? 39.10. Oxygen was 16. And hydrogen 1.01. Who's got an answer for me? I'm not going to do it. You guys need to do it because this is your practice. 56.11. Very good. Very good, Miss K. Very good, Miss K. Or Miss Caitlin. It's because I call you K because my niece is called Caitlin and we call her K. So I'm sorry if I say K. Very good, Miss Caitlin. All right. The next one. Do we have time? I don't think we have time. All right, let's watch the video that's next because I don't want to run out of time and you guys not get to do the questions with me.
How do we calculate the molar mass of something? That depends on whether we want to calculate for an element or a molecule. For our convenience, I've copied down some of the elements from the periodic table onto this sheet so that we can see what some of the numbers are. You'll notice on each square of this periodic table, there's the element symbol, the atomic number, and then there's another number, numbers that increase across the whole way. H, hydrogen, has 1.008. O is 16. These are called the atomic masses of each of the elements. And they will be what we are using to calculate the molar mass of things. For elements, it's really, really, really easy to calculate the molar mass. You just check the periodic table. For example, the molar mass of sodium, just look on the periodic table and you'll see the atomic mass is 22.99. This means that the molar mass of sodium is 22.99 grams per mole. This unit of measure means that 1 mole of sodium atoms weighs 22.99 grams. If we want to calculate the molar mass,
when it comes to molar mass for him, he's presenting it as M sub Na, and then he gives a molar mass. Me, you'll always see me draw 2 lowercase m's. If I draw 2 lowercase m's, all I'm talking about is this is the molar mass of that compound. Or we're going to calculate the molar mass of a compound. Okay? Just real quick.
Of a molecule, things get a little more complicated. We have to add up the masses of each of the atoms. For example, H2SO4 has 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. What we do to calculate the molar mass is take 2 times the molar mass of hydrogen plus 1 molar mass of sulfur plus 4 times the molar mass of oxygen, because we have 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. When you do this math, you get 98.09, and the molar mass is always measured in grams per mole. The molar mass of H2SO4, 98.09 grams per mole. For every 1 mole.
Make sure you indicate the unit, guys. I do take off points if you don't indicate the unit for molar mass. It is very important because that's the grams that equals 1 mole that you're going to be using as a conversion between mass and moles.
Mole of H2SO4 that we have, it weighs 98.09 grams. If we were wanting to calculate the molar mass of something like O2, do the exact same thing. 2 times the molar mass of oxygen. That's all there is to this molecule. So we get 32 grams per mole.
All right. Thank you so much for listening to that. I hope that just makes it a lot easier for you guys listening to it from a different perspective. All right. So, in summary, calculations are described for the determination of molar mass of an atom or a compound. Your review questions that we're going to tackle right now before you go. What is the molar mass of lead? Where do you find the molar mass of an element? And how many moles of chlorine are in 1 mole of calcium chloride? Number 4, how many moles of hydrogen are in 1 mole of the compound ammonium phosphate? And then number 5, calculate the molar mass of calcium chloride. All right, just a second.